You are watching Tech and AI Live. Next, we have a fantastic panel discussion on the use of AI in manufacturing. Joining us today are Jeff Winter, Industry Executive in Manufacturing at Microsoft, Andreas Welsh, Vice President Solution Management, Extensions and Artificial Intelligence with SAP, and Patrick Banger, who is the VP of AI at Samsung. At Microsoft, Jeff acts as an industry advisor, helping US manufacturers digitally transform their business at scale. With over 16 years of experience working for different industrial automation product and solution providers, Jeff has a unique ability to communicate complex concepts to a wide range of audiences, educating and inspiring people from the shop floor up to the executive boardroom. Andreas has been a trusted C-level executive, is a trusted senior C-level executive, senior management, and domain expert across lines of business and industries in more than 80 innovation projects. Most recently, Andreas has accelerated AI and intelligent automation innovation at SAP's flagship ERP product, SAP for S4HANA, and has created an AI mindset across SAP's largest product engineering unit. Our final panelist, Patrick, heads up the AI division at Samsung SDSA. He is responsible for the Brightix AI Accelerator, a distributed ML training and automated ML product, and AutoLabel, an automatic image data annotation and modeling tool primarily targeted at the medical imaging community. He also leads a consulting group that makes AI models for Samsung customers and for many diverse use cases. So Jeff, Andreas, Patrick, welcome to the show.
Hello.
Hey.
Hi, and why don't we get straight into it, because I know we've got a lot of topics to cover today. So Jeff, I'll start with you. Just for a little context, why don't you give us an overview of AI in your opinion? What is it good at and what is it not so good at?
Sure. So I love answering this question, and it's because the idea of replicating human cognition has been discussed and sought after for thousands of years. Artificial intelligence, it really isn't a product, and you could argue it's also not really a technology. And it in itself isn't an invention either. There's no real day we can attribute to its beginning, and probably won't be till its end. I like to say that artificial intelligence is a decision-making tool that's designed to supplement and complement human intelligence. The two big use cases for how AI is used are augmentation and automation. So in augmentation, you're using AI tools, most notably machine learning, to run calculations and simulations to provide data in a way that gives us the ammo we need to make better decisions. They can be technical decisions, business decisions, and even managerial decisions. And this type of AI is taking off tremendously and is an area that every company should be embracing or starting to embrace at this point. Now, automation AI, however, not many are using yet. This is where you give up control and let the AI make decisions for you. And this is one that's inherently difficult for people to fully trust because it's difficult to fully comprehend. For example, think of self-driving cars. How well do you trust them? So automation AI is in its infancy, and this will take years before it's perfected enough and trusted enough to start taking over high-risk decisions in our lives and in our businesses. Now, in addition, we also need to consider what AI is good at and what it's not good at. Machine learning is incredible at sifting through massive amounts of data and identifying correlations and patterns and developing forecasts far better than a human can do. AI is great at replacing tedious, repetitive, and routine tasks. Humans can get bored and make mistakes. Cognitive AI is great at looking for answers to simple questions. Think of chatbots and your autocorrect on your phone, or just finding songs or photos when you don't really remember everything about them. AI is also fantastic at diagnosing diseases and translating languages and even beating humans at complex strategy games. But AI has its limitations. AI has no common sense, which means it doesn't do well in situations it hasn't seen before. Humans have a broad sense of basic background knowledge that allows us to make sense of a situation quickly by understanding what's important and what's not important without needing to run trillions of calculations. For example, we can quickly tell if we walked into a room that we shouldn't have. AI would struggle at that. A 4-year-old can answer this question. Which weighs more, a pencil or a toaster? Which, by the way, that very question was actually asked by Kevin Lacker of OpenAI's GPT-3 language model 2 years ago. and GPT-3 said the pencil was actually heavier. It couldn't find enough data on discussions on the internet about relative weights of toasters and pencils, so it gave the wrong answer. But when asked to compare an elephant to a mouse, it got that one right. AI struggles with extracting meaning from the data, and humans have a basic understanding of physics, gravity, and object persistence, and causality, and many other things that enable us to trace the relations between an object and their parts, which gives us common sense. So whenever I hear someone say, oh, let's use AI to solve that problem, it's immediately a red flag for me that I don't think they actually really understand what AI is. That's like saying, let's use the internet or let's use electricity to solve this problem. It sounds silly, doesn't it? Everyone, especially at decision making level, needs to know generally how AI works, what it can do, and what it can't. And that's why understanding these basics is so important.
Oh, definitely, definitely. And I think obviously with all those benefits, the good and then the other things that we need to consider. Andreas, what are the top areas of opportunity for AI and manufacturing? It's why we're all here today, is to discuss manufacturing. So I wonder if you could kind of shed a bit of light into that.
So see, one of the prime examples for AI in manufacturing that's been around for quite some time is actually around a topic called predictive maintenance. And if you look at how historically maintenance of assets, of machines has been done, right, you can say on one hand, we just let it run, and when it fails, we go and we fix it. Sure, you can do it, right? But we can also do better now. So this has evolved into fixed intervals of maintenance. Say every 3 months or every 6 months, we service this asset. But do you really need to service it at that interval? Maybe you need to service it sooner or maybe a little later, depending on the usage, depending on wear and tear, or conditions like temperature or vibration. And so come in predictive analytics, AI, machine learning, all our favorite buzzwords here, and we're able to analyze data that you get from those machines with your Internet of Things connected machines. So especially to that point, temperature data from sensors, vibration data, how has that machine actually been used, and when do we typically see patterns in that data before a failure occurs? So if we see that same pattern, we know, hey, it's about time that we send somebody out to replace certain parts and do that maintenance. So instead of doing reactive, do it proactive in that sense. Another great example that I like is from that area of quality management and inspection. You know, you probably tried some of this out at home, some of the base technology. In one of my favorite consumer shopping apps, you can take a picture of an item and look it up in the product catalog. What is this? You know, it's a bottle of water, it's a 1 liter bottle, this and that brand, for example. That same technology of recognizing objects can also be used to recognize defects in products that you receive on your shipping dock and loading dock, or those that you manufacture. Are they within tolerance? Are they out of tolerance? Are they broken? Right? Does it meet my quality standards or not, basically? And you know, maybe even to the level of, are all the labels attached, or is some crooked, or maybe folded over or something? So really great opportunities using machine learning, AI for computer vision to detect quality defects and do a visual inspection of items. Now, if you look at this manufacturing example even broader, and you start that sooner upstream in that process, you can think of something like demand sensing. What's the number of quantities, right, and of these materials and products that I need to have ready on the shelf at my distributor or at my retailer, so I don't run out of stock. And so if we frame that problem also as a supply chain problem, you know, instead of doing simple regression and assuming, you know, that these are the quantities I typically need, you can use pattern recognition, additional data outside of just your manufacturing systems and ERP systems, and pull all this together and create a real-time demand sensing forecast. So going down from, you know, planning for just 1 or 2 days in advance, all the way to 6 weeks in advance. And that's a huge advantage because it allows you to source your material differently, to plan your production differently, have fewer rush orders, and the like. So you don't run out of stock. And then really the last example, which is something I've talked to many customers of ours about as well, is to help with the creation of bills of material and routings. So what are the right steps and the right sequence when you manufacture a product? And what's the most efficient way to put these steps in a sequence? So you can learn from historic data of similar projects that you've run or similar components that you've manufactured, and apply these learnings to help the BOM engineer create these bills of material faster, just having to adjust little bits here and there where needed, as opposed to starting all of that from scratch. So lots of tremendous opportunities all around.
No, definitely. It sounds like there's a lot of opportunity for the industry, which it almost kind of, it doesn't then make sense that the adoption of AI in manufacturing isn't as big as you'd expect. So Patrick, why is AI adopted but used so little in the manufacturing industry?
Yeah, it's a very interesting conundrum that most people in manufacturing talk about AI a great deal. At the conferences, you see maybe 30 to 40% of all talks given are about AI. Every C-level executive in every manufacturing company I've come across says, oh, AI is important and we need to use it and this and that. But what is actually being used on the shop floor? Actually, very little. And there are some common reasons for that. First, I'd like to give an analogy. AI is a little bit like having an intern. So on day one, the intern comes in, is all well-meaning, but doesn't know anything about your industry or your facility or the manufacturing that you do. And so what does the intern do? The intern gets experience by simply being there. Seeing this example, seeing that example, like Andreas mentioned, right? Some machines fail. Typically they don't, of course. There are some scrap parts produced, but typically the parts are not scrap. So you gain experience. And over the first few days, you gain experience of the typical things that happen a lot. And as the months go by, you gain a very small amount of experience of the atypical things that happen very rarely. And there are some other things that happen so rarely that the intern, in whatever 6 months or so that the intern might be there, just doesn't see it all. AI is like that. You have to provide it data to learn from, and the data will necessarily overrepresent the normal case, and it will underrepresent the not so normal case, and it will not represent at all the very rare case because it's rare. That's the first problem, data availability. For example, in the predictive maintenance case, most machines in the manufacturing industry fail once every few years. And that's rare enough for you simply not to have data on it, or for you to have maybe 1 or 2 data points on it. Now, you can't learn from 1 or 2 data points. It's just not possible. A human being may be able to draw some abstract lessons learned from a single example, but the computer doesn't have that capability. Right, so data availability is the first problem. We just don't have many of the interesting data points that we would need for a particular use case. The second thing is the cost of data preparation. If you think, again, having an intern, you have to put together a curriculum to teach that intern. Now, typically the way we do it is we simply keep the intern around for a very long time. The cost is put on the intern themselves. Now, if you think of having lots of them, like in a school situation or university situation, what you do is you have to prepare a curriculum. Now, that takes a very long time. It takes very experienced professors and sitting around for some time, collecting examples and preparing them very carefully for the students. AI is exactly like that. We, the industry professionals, have to very carefully prepare a curriculum of teaching. That is to say, we have to collect the data set that is representative of the situation. So we have to underrepresent the normal case and overrepresent the rare cases that we actually want to deal with. We have to label that data. So to present, okay, this is an example of a scrap part. And the fact that it's scrap is over here in the lower right-hand corner. That's the thing we want you to detect, dear AI, right? So we have to carefully prepare that, and that costs money and time. And therefore, the company has to think about the cost benefit ratio, which is the third barrier here. What is the benefit? Well, before you do something, the benefit is uncertain. You have to actually do it in order to experience and measure the benefit. And so if you present that to financial decision makers and you say, okay, the cost is pretty clear, the benefit is pretty unclear, let's do it. That's not a very good way of going about it, right? And since the reference use cases in your competing companies and the other manufacturing facilities are all missing because they also haven't adopted it, it's very difficult to argue to spend, I don't know, a couple $1 million on this new AI initiative of yours, which may or may not pay back. So people have to take a risk. Manufacturing industry is not very good at taking risks. In addition to the finance, there's of course the risk of your AI system just not working, or not working in the cases that we really needed to, right? So the last is the fear of the unknown. Management is generally fearful of things they don't know, things they don't understand, things that they haven't done before. You know, purchasing a new manufacturing machine is something that everybody's done before and they understand how to do that. Introducing an AI system carries with it a lot of unknowns. Particularly human beings will have to change their behavior. Predictive maintenance is not just about introducing an AI system that will make the prediction, but the maintenance department, which might be a couple hundred people, will have to adjust their way of doing things. They don't want to. So there's a lot of that going on as well. So in sum, those are the big four reasons why the manufacturing industry has adopted it very little to date.
That is really interesting. And I think that fear of the unknown definitely leads to a lot of misconceptions because people aren't kind of sure of the technology, then therefore these misconceptions kind of start to circulate. So what do you think, Andreas, I'll give this one to you. What do you think are the biggest misconceptions around AI projects?
Well, I'd like to offer a little bit of a different perspective, right? Because I feel a lot of times we hear, hey, AI is so complex, I don't know where to start. And to me, the question is, you know, what does doing AI actually mean to you, right? It can have different flavors. It doesn't mean, or doesn't have to mean, that you start from scratch with everything you do. So there are a lot of AI capabilities in modern business applications that you might already be using today, or that you might have access to. So my typical call to action is, you know, look at the software you already use and see what is in there that you could be using, or is there a newer version that you might be able to use that has AI embedded already. Not everything needs to start with a toolbox. Right? Start from scratch, go figure out what problem we can solve. Certainly a way and an option when you face a problem that is very specific to your industry, to your niche, to your own business. But it doesn't always have to be the starting point. And to Jeff's point earlier, right? AI has so many facets and so many flavors. If it's about doing AI and you want to see where and how you can use it and what benefits you can get, and to Patrick's point, managing all that change that you need to manage anyways, right? Maybe you don't start with something like a visual inspection because you don't have enough data, or you don't have enough faulty parts to train this thing with. But maybe it's a chatbot that helps your customers, or maybe your employees on the shop floor find information a little more quickly than navigating through a portal and figuring out where in this tree I find the information that I need. So really my call to action is look at what you're already using today. A lot of the products already have AI embedded, and that reduces the barrier of entry to get started and to get benefits from AI today.
Oh, brilliant. And thinking about that call to action, Jeff, when do you think manufacturers should start investing in AI?
It's a good question. I think one thing that makes AI so interesting, especially compared to most other technologies out there, is how ubiquitous it is in its application. I mean, it impacts nearly every industry, nearly every department, whether it's finance, sales, marketing, operations, HR, supply chain, engineering, you name it, and even every job function from the shop floor all the way up to the CEO. And because of that, AI is already being utilized more than most people realize. And even if you aren't intentionally using AI to solve problems, just kind of like Andreas said, it's already embedded in most of your software platforms. And this is mostly driven by advancements in other technologies, such as computing power and custom computing resources, and even the internet, sensors, and most definitely the development of machine learning algorithms and models. So when should manufacturers start investing? I would say now. Most manufacturers are using multiple software platforms already that collect and store data, whether it's MES, ERP, QMS, PLM, WMS. Yep, whole bunch of acronyms there. And the list goes on. But basically, all of them, they all collect data. So by just plugging that data into the cloud, you can start to train machine learning models to identify patterns and correlations and predict forecasts pretty quickly with little cost. According to IDC, 87% of the manufacturing industry has enterprise business strategies now relying on the cloud. So that means there's a good chunk of data that's already there, ripe for the picking. Now, of course, kind of like Patrick said, the only way you're going to get value out of this data is if you have processes in place to take actions based off the findings. But the point here is that you can extract value immediately.
Brilliant. So I think with that, it's obviously everyone watching, I'm sure, will be going off and investing in their AI on their phones as they watch this. But we kind of think, skip ahead to the future, Patrick. So obviously we talk about the benefits that people can realize right now, but what do you think is the 5-year future of AI?
Yeah, thank you. That's a really good question. Now, I know that a lot of people, both in the industry as well as in the general population, have watched movies like The Terminator and similar movies coming out of Hollywood. So there is a concern out there that, you know, the future of AI, either the near or the medium term future, will result in artificial general intelligence. Now, that's a term that means is that essentially that AI, a computer, has an intelligence comparable to a human being. Therefore, AI could do many different things simultaneously, and could be malicious. Now, as a practitioner of AI, at the forefront of currently available technology, I can give you my word of honor that we are extremely far away from having such capability. In fact, my personal opinion is that we will essentially never get there. On the scales of my personal lifetime, I don't think it will happen in my life. So I don't think we need to be worried about that general intelligence. What we have today is what we call narrow AI. It's AI systems that can do one job very well, and it's a very, very well-defined job, very specific job. And like was mentioned previously by both Jeff and Andreas, it's typically a very repetitive job that people can also do very well, but people kind of get frustrated and tired because if you have to do the same thing every 5 seconds for the entire working day, that's very dull. AI is great at those things. The example I think that everybody is thinking of in the next 5 years is autonomous vehicles, right? That's the example that we will all see on the streets in our cities in the next 5 years. It's something that scientifically is done. Autonomous vehicles exist. They exist as prototypes today. There are cars that go close to that you can even purchase today. They're, of course, not widespread. The challenges there are, in fact, manufacturing. We have to produce enough many of them, and we have to overcome some legal boundaries, and we have to get them out there to the population. But that's the example of AI that you will see in the next 5 years. Another is in healthcare. You will see yourself being largely diagnosed by AI systems. AI systems will help treat you, will help discover and produce the medicines that you will take. So there's another manufacturing industry example. That's the future as in terms of use cases. Currently, there are two big research topics in artificial intelligence for those of us who actually make the AI systems, and those are ethics and explainability. Ethics is very important because currently there are numerous AI models that discriminate either against certain groups of people or against certain things that we would consider typically unethical, like an autonomous drone that has the capability of killing. That's typically unethical, right? And if you have an AI system on it that completely guides that and decides who to shoot, that's not very ethical. So AI ethics is an important research topic. What do we consider ethical? How shall we deal with this in an automated system that's scalable, where there is no human in the loop that can hold it back? The answer to that is unknown at present. It's a research topic. Then explainability. For many use cases, healthcare is one of them. Popping out the answer is not very helpful, right? You come in, I tell you you've got cancer, and that's it. You don't get any more than that. That's not great, right? You want an explanation of why you have that, on the basis of what data did I make that determination, and then some further explanations. How much time do you have, and what should you do about it, and things like that. So I need an explanation. Otherwise, the diagnostics is useless. How to provide that in a form that is digestible, acceptable, understandable to the audience is something that at the moment we don't know. It's a research topic again. Over the next 5 years, I anticipate that we will have some results that will help us do that. And lastly, I think we need to build trust with the general population. I think people generally do not trust AI systems once they become aware that they're actually dealing with one. To the point that both Jeff and Andreas made, all of us interact with AI models multiple times a day, and we don't realize it, right? Prices that you pay online for shopping or airline tickets, that's AI, right? Scheduling you onto modes of transport, that's AI. Things like that, you don't even realize that this is happening to you. But once you do realize that you're interacting with AI, generally there's a little bit of a mistrusting going on, right? Is this in my best interests? Ethics, why is it doing that? Explainability, things like that need to come in to build trust. And then once we have trust, then also these change management aspects and implementation aspects in the manufacturing industry will become a great deal easier.
Brilliant. So thanks for that, guys. We have had questions come in from the audience, but sadly, I don't think we're going to have time to ask them today. We went into loads of detail, and it was really great to hear that. But unfortunately, we are running close to time. So I think we're going to have to wrap it up there. So thanks, Jeff, Andreas, and Patrick for joining us today. It was a really interesting discussion. I always enjoy talking about AI. So thank you so much for joining us.
You're welcome. Thanks for having us.
Thank you. And thank you all for tuning into this discussion, and make sure you stay tuned to check out the rest of our speakers for Tech and AI Live.